In this tutorial, we will consider how to calculate cooling load, a calculation that we need when designing refrigeration systems. Cooling load is the rate of heat energy that is removed by the refrigeration system. We need to calculate the total rate of heat energy that is present in that space that we are trying to cool down. The best way to consider this is by looking at an example. Let's say that we have a room that we want to cool down to a certain temperature. So let's look at various ways that heat can actually transfer into this room. Of course, our refrigeration system will then need to remove that heat to maintain it at a certain temperature. So the heat can transfer through the walls of this room. Heat can transfer from the roof. Heat can also transfer from the floor. And also heat can come in through the door when the door is open. And if there are people inside, of course, people are also generating heat. So we have to consider what's the amount of heat generated by number of people that are inside. And also if there are lights present in the room, and if you are operating any machinery in the room, that will also generate a certain amount of heat. If this room is used for storing fresh products, such as fruits and vegetables, then we must also consider the amount of heat generated due to heat of respiration. So our procedure to calculate cooling load involves determining all the ways that heat can enter the room, including heat generated within the room. We will consider a numerical example. However, for the sake of simplicity, we will only look at the heat generated due to stored products. A more complete analysis, of course, will involve accounting for the various ways that heat can enter this room, as we have seen in this example. So we have an example here where we want to calculate the cooling load of storing 3000 kilograms of cabbage at 5 degrees C in this cold storage room. And we are going to ignore any other heat transfer into the room for this particular calculation. So we are given amount of cabbage as 3000 kilograms, and we will need to determine the value of heat evolution, that is the heat of respiration of cabbage at 5 degrees C. Now, as you know, most fruits, vegetables, and also cereal grains, they all respire. And there is a certain amount of heat of respiration that is given off by these respiring products. And when we design cold storage to store those products, we need to know what is the heat of respiration. So that means we have to look up in some reference, and here we can see a table that shows heat of respiration for various products at different temperatures. And we note that for cabbage, the heat of respiration at 5 degrees C is 28 to 63 watts per megagram. Note that M is capital, and M here represents megagram. So we will select the higher number in order to make sure that we have a sufficient safety margin. So we will choose the larger value of 63 watts per megagram. Next, we can go ahead and then calculate that the rate of heat evolution, or the heat of respiration, equals 3000 kilograms times 63 watts per megagram. And of course, we can convert megagram to kilograms because 1 megagram has 1000 kilograms. So number of these units will cancel out, and we will be left with 189 watts. So the cooling load then for storing cabbage in this room at 5 degrees C, 3000 kilograms of cabbage, is equal to 189 watts. So this example shows that if we were to consider only the product heat that is given off, that we must remove with our refrigeration system, then we must design our system with a cooling load of 189 watts.